Hello math peeps, how you doing out there? We are almost done. 3 more sections to go. These sections are not in your book. Well, they're in your book in chapters 12 and 13 thrown out there, but I'm going to concentrate on a couple specific things that I need you to know to help you prepare for pre-calc next year. Ultimately, before next week, or by the end of next week, we're going to be learning the unit circle. How to use it, what is it, what's it for? In order to learn that, we've got to step back and remember a few things. So I'm going to go over a couple things that you learned in geometry class that have to do with these trig ratios. Then we're going to apply it a little bit today, and then more in the last 2 lessons, which will be posted next week. Your ticket out the door is going to be a 10-question test. I'm going to ask you to know what these 9 values are. And I want you to know the exact value. I can plug this in the calculator. If I plug this in the calculator, I get 0.5. If I plug this in the calculator, I get this answer. Right? If I plug this in the calculator, I get this. What do these even mean? Well, what's sine mean? Sine is a ratio of 2 sides of a right triangle. If I have a 30-degree angle, the opposite side divided by the hypotenuse is going to be a half. That's what we're going to explore in this lesson. So what I want you to know, I want you to know what these answers are, and not these decimal values. I don't care about these. We're going to use decimal values when you have to figure stuff out, which is great. But what I want to know is, where did these come from? And do I know an exact value that's not written like a decimal? That's what we're going to memorize. Okay, but we're going to start with this. We know these are true. Why? All right, reminder, trigonometric ratios. You remember them. You have 3 sides of a triangle. And don't forget, here's your angle. We're going to call it the Greek letter theta. Now, the one furthest away, the one that is created by the opposite side, as we call it. See, this angle creates the opposite side. Adjacent and hypotenuse are both connected to this angle. In fact, adjacent means next to. But you've learned the hypotenuse for a long time. The hypotenuse is always across from the right angle. So as long as you know those, you're okay. So I can take opposite over adjacent, make that into a ratio. I can take hypotenuse over opposite. I can take opposite over adjacent. These two aren't, oh, they are the same. How about I make it adjacent over opposite? So are these two the same? No, they're not. How many can I make? How many distinct ratios can I make? Well, I got hypotenuse over opposite. So now I need an opposite over hypotenuse. There's 1, 2, 3, 4, 5. Did I miss one? Adjacent over opposite. Oh, I got that twice. Geez, that's not good. That's not going to help at all. Adjacent over hypotenuse. Let's see, we've got adjacent over opposite, adjacent over hypotenuse. Good. Hypotenuse over adjacent we don't have. I think we got them all now. I have adjacent over opposite, adjacent over hypotenuse. I have opposite over adjacent, opposite over hypotenuse. Hypotenuse over adjacent, hypotenuse over opposite. That's all 6. That's 6 possibilities. You might be saying, well, could I do opposite over opposite? I mean, technically you could, but those ratios would always be 1, so they don't really help us. Okay. These 3 names, sine, cosine, and tangent, and these are short for sine, cosine, and tangent, are ways to describe these ratios. And if you remember from geometry, the sine was opposite over hypotenuse. So here it is right here, opposite over hypotenuse. Cosine, remember that one? That was adjacent over hypotenuse. And our lovely tangent was opposite over adjacent. So what about all these? Well, these also have names. Notice how hypotenuse over adjacent is just the inverse of this, or the reciprocal, I should say, not the inverse, the reciprocal, just flipped over. Well, this is called secant. It has a name. We're not going to worry about that name for right now. Adjacent and opposite has a name. Okay? it is the reciprocal of tangent. This one's called cotangent. Again, we don't need to know that for right now. And lastly, we have opposite over hypotenuse, which is the reciprocal of this. This is called cosecant. Those are names that you will learn, but you don't need to learn them just now. So just these three. And most likely, although I can't guarantee it, you might have learned this little shortcut to remember. This has been around for a long time. When I was in school, good old SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So all the first letters. SOHCAHTOA. So what is the trig ratios for this triangle? Well, we don't have the hypotenuse. If you remember, that's the Pythagorean triple 5, 12, 13. Now, if you didn't know, just use Pythagorean theorem. 25 plus 144. Add that, you get 169. Opposite of square is the square root. So it's 13. And we're only going to use the positive values. We're talking about a distance, a physical distance. Okay, not a direction, just a distance. So 13. So what's the sine of theta then? Our opposite angle is 12. Our hypotenuse is 13. Cosine. Adjacent is 5. Hypotenuse is 13. Remember, sines and cosines are always over the hypotenuse. And lastly, the tangent. It's opposite over adjacent. It's 12 over 5. And if you kind of look at the little pattern here, say you got those. Tangent is also sine over cosine, 12 over 5. All right, don't know the hypotenuse again, but this one's not a Pythagorean triple, so we got to figure it out the old-fashioned way. We'll call it C this time. That's 29. So the square root of 29 is our value for C. This is the square root of 29. It cannot be simplified. That's it. So what's the sine? Here's our angle. Opposite is 2. 2 over root of 29. Now we'll get back to that one. We don't like roots in the denominator, but let's figure these out first. Cosine is 5 over root of 29. Tangent is 2 over 5, opposite over adjacent. All right. And how do we simplify a radical? Or rationalize a denominator, I should say. You multiply it by, really, itself. Root of 29 times root of 29 is 29. So this answer doesn't look any better, does it? Like, it's not more simple than that, but there's no denominator that is a radical. And that's something that we, as mathematicians, decided a long time ago we were going to avoid. Kind of like you're reducing a fraction. We always want the answers to look the same, but isn't 5/10 the same as 1/2? But we're trained to reduce them. Same here. We're kind of trained to get rid of the radical. All right, there we go. The second thing I need you to remember. A 45, 45, 90 triangle. Do you remember the little pattern for these? If one of these sides was x, then the other leg had to be x as well. These two angles were the same, these two sides were the same. And if you do a little Pythagorean theorem, you get this. Now, if you don't remember that, that's not a problem. Just see if you can think about how you would do this. Okay. How do you find the hypotenuse when you know a leg? Well, you multiply it by the root of 2. And if you happen to go the opposite direction, how do you find a leg when you know the hypotenuse? Well, you divide it by root of 2. Okay? So real quick, just a little refresher. If this is 7, that's 7. The hypotenuse is 7 roots of 2. That's it. 1, 1, 1 root of 2, which is just root of 2. Oh, the hypotenuse is 3 roots of 2. We have to divide by that. So 3 roots of 2 divided by root of 2 is 3. These are both 3. It's pretty easy to see the pattern now. Here's a weird one, though. It's 10. Well, I got to divide it by the root of 2. Remember? No radicals in the denominator. So on the top we get 10 roots of 2. On the bottom we have root of 2 times root of 2, which is 2. So that's 5 roots of 2. There's another triangle that you also learned, the 30, 60, 90 triangle. So we're going to call it x. Now this is half of a equilateral triangle. So if that's really an equilateral triangle, I know all three sides are the same. If this is x, which means every side is 2x long. And do you remember the 60-degree side? And we call it 60-degree side because it's across from the 60. That was the short side multiplied by the square root of 3. Alright, so how do you find the hypotenuse when you know the short leg? Well, if the short leg is x, the hypotenuse is twice as much. So you just double it, or you multiply by 2. How do you find the long leg when you know the short leg? Well, there's a little pattern here. You multiply by root of 3. How do you find the long leg when you know the hypotenuse? Well, first you got to take half of it, then multiply it by the square root of 3. So divide by 2, then multiply by 3. And some of you really savvy mathematicians and numerologists would say, oh, just multiply it by square root of 3. Multiply it by the square root of 3 over 2, and you'd be correct. All right, how do you find the short leg when you know the long leg? Well, how do you go backwards? If you have to multiply to get from x to x roots of 3, to go backwards, you divide by root of 3. Okay. Well, there's your little pattern for the 30, 60, 90. So see if you remember these. If I know the short side is 7, that means the hypotenuse is 14. The 60-degree side is the short side multiplied by the square root of 3. And here we go again. Short side is 3. Hypotenuse would be 6. The 60-degree side would be 3 times the root of 3. All right, 12 is the hypotenuse. Short side is 6. This is 6 roots of 3. Oh, I know that that's 2 roots of 3, so if I'm going to go backwards, I have to divide by the root of 3. Well, that makes that 2. If I double 2, I get 4. So the only strange one is this. You have 18 as your 60-degree side. So to go back to the short side, I have to divide it by the root of 3. Well, as you know, we don't like root of 3. 18 roots of 3 divided by 3. What's 18 divided by 3? 6. All right, and then to get this one, you double it. All right, so if you've got all that, here's where we're going to put it all together. If this is 3 and this is 3, this is 3 roots of 2. I mean, here's like the thing. Here's what I want you to know. So what's the sine of 45 degrees? Well, here's a 45-degree angle. Sine is opposite. Hypotenuse is 3 roots of 2. Looks good, doesn't it? We'll come back and simplify it in a second. Cosine of 45, or the adjacent over the hypotenuse. Well, the same thing, isn't it? Because 3 is the leg no matter where you come from. Opposite and adjacent are both 3. So the sine of 45 and cosine of 45 are the same. Now what's the tangent of 45? So it's the opposite divided by the by the adjacent. So it's 1. Now again, so I'll come back to simplify those, but let's do this. If this is 10, this is 10, this is 10 roots of 2, our sine would be, doesn't matter which one, they're both 45. Opposite is 10 over 10 roots of 2. Same thing with cosine. Adjacent is 10, hypotenuse is 10 roots of 2. While the tangent is opposite over adjacent, they're both 10. So notice how the tangent of 45, there's always 1. Now let's simplify these. The first thing I know is that these 3's are going to cancel. I'm going to get 1 over root of 2. Can't have a root of 2 in the denominator. So 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is the square root of 4, which is 2. So with that same logic, this will be the square root of 2 over 2, because we know these are the same. Well, what do you get here? The 10s would cancel. You get 1 over root of 2. Well, guess what? That's what you had last time. So after a little simplification, all right, is sine of 45 always root of 2 over 2? It is. Is cosine of 45 always root of 2 over 2? It is. Doesn't matter how big the triangle is, because remember, these are ratios. It's always going to be the square root of 2 over 2. And will the tangent of a 45-degree angle always equal 1? Yeah, the opposite and adjacent will always be the same. The tangent will always be 1. So what I want to do is, let me jump down to this right now, our final page. What did we figure out for these? The sine of 45, square root of 2 over 2, cosine of 45, and the tangent of 45. That's true all the time. Alright, so here's our 30, 60, 90 triangle. That's 3, which means that's 6. And this is 3 roots of 3. So here's my 30-degree angle. So the opposite is 3 over the hypotenuse, which is 6. Okay, I'll do our simplification in a minute. Cosine of 30 is 3 roots of 3 over the hypotenuse, which is 6. And tangent is opposite over adjacent. Okay, let's do this triangle. Hypotenuse is 10, means that's 5, and that's 5 roots of 3. So the sine of 30 is 5 over 10. Well, what do you know about 3 over 6 and 5 over 10? They're both a half. Sine of 30 degrees is always a half. Cosine of 30 would be 5 roots of 3 over 10, or adjacent over hypotenuse. We see the little pattern here. The 3's go into the 6 twice. 5 goes into 10 twice. Okay, don't need to rationalize. The denominator is a 2. Cosine is the square root of 3 over 2. Always the square root of 3 over 2. Alright, look at our tangents here. Oh, let's do this tangent. Opposite is 5. Adjacent is 5 roots of 3. So you can see the similarities here. Let's simplify. These 3's would cancel. 1 over the root of 3. Don't want a root of 3 on the bottom. Square root of 3 over 3. Will that happen here as well? Sure it will. We have 1 over the square root of 3. Square root of 3 on top, 3 on the bottom. So look at that. The sine of 30 is always 1/2. The cosine of 30 is always the square root of 3 over 2. And the tangent of 30 was the square root of 3 over 3. Looking for patterns, always, because that's what mathematics is, the study of patterns. Alright, let's do our 60-degree angle now. Same triangles as the last. So this fits 3, this is 6, this is 3 roots of 3. Alright, so sine of 60 is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Alright, does that hold up for this one as well? And of course, you know it does. Sine of 60 is opposite over hypotenuse. Cosine of 60 is adjacent over hypotenuse. And tangent of 60 is opposite over adjacent. So if I simplify these, 3 goes into 6 twice, 5 goes into 10 twice. The sine of 60 is always the root of 3 over 2. 1/2. 1/2. 3's cancel, square root of 3. 5's cancel, square root of 3. Look at these. Are these always the same? They are. Let's put these in here. Sine of 60 is the square root of 3 over 2. Cosine of 60 is 1/2. Tangent of 60 is square root of 3. So look for patterns here. And I say, I want you to these memorize eventually. So cosine of 30 is 1/2. Sine of 45 is root of 2 over 2. Sine of 60 is root of 3 over 2. Look at it. 1, 2, 3. 3, 2, 1. Oh, the sines and cosines. And look how the sine of 30 is equal to the cosine of 60. And the cosine of 30 is equal to the sine of 60. And the tangents, a little stranger. All right, so see what you can do to think about those. And there's no book assignment for this. I'm only going to ask you to take the ticket out the door on the computer, and the questions are going to be these 9 questions. Oh, with a bonus question, but it's all related to this chart here. So see what you can do. Do your best to not look at anything when you answer those questions. But I'm not going to know if you did or not for real. So that's totally up to you. It's your integrity we're talking about. Again, I don't care if you get any of them right. If you get them all wrong, doesn't mean anything to me. But by next week, by Friday of next week, June 5th, our last day of school, I'm going to show you a way to have these up here. All right? And it's all based upon this. So thank you for listening, as always, and I hope you have a great day.